Hi, fifth graders. This lesson is all about patterns when multiplying a whole number by the powers of 10. So in the last lesson, we talked about powers of 10, exponential form, sort of what does 10 to the third mean. So now we're going to take other numbers and multiply it by that 10 to the power of whatever and see some patterns there. So by the end, hopefully you'll be able to determine the products of numbers multiplied by powers of 10 written with exponents and describe the pattern. So I think you'll see that even though it is a lot of words, it's maybe not as hard as you might think. So here's our problem to think about. The distances from these planets to the sun are shown as multiplication expressions. How can you determine the value of these expressions? So this is something that scientists do because the numbers are so big. If you wrote it with all the numbers, it would be a really long number. So they shorten it by using the exponents. But what does that number actually mean? That's what we're going to figure out. So first, let's look at Mercury to the sun. 36 times 10 to the 6th. So first, we'll write it using factors of 10. So we're writing it just sort of out as an expression with, instead of writing 10 to the 6th, what all those 10s look like. So on the first line on your paper, I want you to write 36 times, and then 10 to the 6th. How many 10s is that? All right, 6, because it's 6 to the 6th power. 2, 3, 4, 5, 6. Right? That's what 36 times 10 to the 6th means. This is the 10 to the 6th part. So now, if we think about, okay, we did that. Now, what is 10 to the 6th power? What do all those 10s, what number does that end up being? Well, like we talked about last time, I can count and say, okay, I have 6 10s. That means I'm going to have a 1 with 6 zeros. Oops, 1, 2, 3, yeah, that's 6 zeros. Okay, so on the next line, I actually want you to write 36 times 1 million, because we took all those 10s and we figured out what that answer is going to be. So that next line is going to be that. So you had 36 times 10 times 10 times 10 times 10 times 10 times 10. Now I have 36 times 1 million. Now we're going to figure out, well, what is that number? Talked about this. I can do 36 times 1, which is 36. And then I just have 6 zeros, so I can put on my 6 zeros. Yes. And then count 1, 2, 3, comma, 1, 2, 3, comma. So put that on your third line. So 36 times 10 to the 6th power is 36 million. 36 with 6 zeros. You might already sort of start to see the pattern that we're going for. So look, those are the 3 things you just wrote. They're the 2 things you just wrote. And again, what do you notice about the number of zeros? Well, the exponent is the same as the number of zeros. So go ahead, write that on your paper. The exponent is the same as the number of zeros. So you don't always have to do those steps every time. You can just look and say, okay, it's 10 to that. That means I'm going to have that many zeros. Remember, it only works with 10s. 5 to the 6th power is not going to be 5 with a bunch of zeros. But with 10s, it's a nice pattern. So let's apply that to Neptune. Neptune is 3 times 10 to the 9th. So on that first line, we're going to do the same steps as before. So we have 3 times, and then we're going to write 10 nines, a lot of nines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because I really want us to see 10 to the 9th power is 9 10s multiplied together. So that's your first line. Your second line is going to be 3 times 1 with how many zeros? 9 zeros. 6, 7, 8, 9. Sorry, it doesn't fit on my screen or in that little box. Hopefully your line is long enough. It's 1 billion. So we have the thousands, the millions, then the billions. And so now we can figure out, well, what's that going to be? 3 times 1 is 3. And then I need 9 zeros. 7, 8, 9. We're going to put that on your third line. 3 billion. So Neptune is 3 billion miles from the sun. So farther than Mercury. Mercury is the closest planet to the sun in our solar system. Neptune is the farthest. All right. If you need to do the get it written down, just rewind it. So, when multiplying by powers of 10, the exponent tells us the number of places it needs to go to the left, which is the same as the number of zeros, right? If I put 1 0, it moves 1 place. 2 zeros moves 2 places. That's one thing the zeros do, is just get it in the correct spot. So, how would patterns help me in this? Well, I don't have to do all the 3 steps we did on the other numbers. I can just say, oh, this has a power of 2, so I know it's going to be 32 with 2 zeros. So 3,200. This one is 10 to the third power. So 32 with 3 zeros, or move that 32 3 places over. This one I'm going to move 32 4 places over because it's 10 to the fourth. And if you're still needing to write out like 32 times 10 times 10 times 10 times 10, 32 times 10,000, 320,000. That's fine if you need to do those 3 steps to really get that pattern in your brain. Let's do some more practice. It'll be your turn to choose now. And again, think, could I explain this pattern to somebody? Because if I could explain this pattern to somebody, I probably understand it pretty well. So we're just going to do one of these. I want you to choose what is 12 times 10, or 12 times 100. Did you get it? Hopefully you got that it is 1,200. Right? 12 times 1 with the 2 zeros. What about this third one? 24 times 100,000. Hopefully you got it. 24. I can count 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Notice that because 24 was longer, it was 2 digits, it got longer. So it's not the same length as this, it just has the same number of zeros. So it's 2,400,000. Let's do one with the exponents now. So if I have 32 times 10 to the second power, or 10 squared. All right, hopefully you got it. 33 with 2 zeros, because we're seeing the pattern here. So 3,300. Sorry, that comma ended up in a weird spot. And I know I'm going quick, so if you're like, whoa, I am not understanding this, pause, ask for help, watch the rest of the video, ask for help. It's fine to need more explanation. Not a problem. Let's do the middle one. 57 times 10 to the 5th power, or the power of 5. Hopefully you got it. 57. How many zeros? 5 zeros. Put my commas in. 5,700,000. And again, notice how much longer that is to write than this. Especially like if you think back to the 3 times 10 to the 9th, was much shorter than writing 3 billion. So that's when it can be really handy if I have to write these big numbers to shorten it up. All right, I'm going to skip ahead to one where we are figuring out what the power is. So 43 times something equals 4,300,000. See if you can figure it out. Did you get it? So this one is sort of thinking in a different way, because I can say, okay, I have 1, 2, 3, 4, 5 zeros in my answer. So I know what I multiplied had a 1 with 5 zeros. So it's either 43 times 100,000, or I could write that as 10 to the 5th power. So either way, either 43 times 100,000 or 43 times 10 to the 5th power will get me 4,300,000. So I just have to think, how many zeros did I add on? I started with none, I added on 5, so I multiplied by 10 to the 5th. All right, 28 times something equals 280,000. What is it going to be? All right, hopefully you got it. Seeing those patterns? 1, 2, 3, 4. Again, I started with no zeros and I added on 4. So it would be times 10 to the 4th or times 10,000 because that has 4 zeros. Because if I started with 1, I would have only added on 3. But if I started with the 0, I added on 4. All right. If you need more explanation, no problem. I'm more than happy to help with any questions you have or with your practice. So good luck.